You are listening to The Vocal Technologist. Spoken Tech for your ears.
Welcome back. It's that time again, Tech Tuesdays, and today we're really diving headfirst into the engineering side of things. We're going to look past the usual buzzwords and, focus on what actually happened out there, what broke, what lessons we should be learning, and maybe some tools that are, well, poised to change how you work.
Yeah, definitely. We've got a stack of updates here covering like major cloud failures, how companies are getting serious about their CI/CD pipelines, and of course the AI explosion, even down to the terminal.
Right.
And the idea is really to pull out the key knowledge nuggets, the stuff that actually helps you build, maintain, and scale systems faster and maybe more reliably. That's the goal.
Okay, let's start with reliability then, because you can't really talk about DevOps without talking about when things go wrong. And boy, did things go wrong with that big AWS outage, US East 1, October 20th.
Oh, yeah. That was a big one. When US East 1 has a problem, it's like the whole internet feels it, right?
Definitely.
And this wasn't just a little blip. We're talking up to 15 hours for some services, impacting, I think the number was over 140 services in total. The core issue, the thing engineers really need to understand, was DNS resolution failures, specifically for the DynamoDB endpoints.
Ah, okay. So the service itself, DynamoDB, might have been okay internally, but nobody could actually find it reliably through DNS.
Exactly. And that's what caused that huge ripple effect, taking down massive names like Snapchat, Reddit, Venmo, just a cascade failure.
Scary stuff.
And it really, really hammered home the point that, look, multi-region architecture isn't just a nice to have anymore. It's non-negotiable. Even if your app isn't global, you just cannot bet the farm on a single cloud region staying up forever, not even the biggest one.
That makes sense. Resilience isn't optional. It's basically table stakes now.
Right. It's a mandatory cost of doing business online.
But, building for multi-region isn't cheap, is it? Data replication, consistency challenges, higher ops costs. Are companies really stepping up?
Well, the materials suggest the smart ones already had, or were well on their way. And this incident probably lit a fire under everyone else. We even see this kind of thinking bleeding into how companies manage their configuration, like Slack's work on their Chef infrastructure.
Ah, right. They realized one big Chef setup was too risky. A huge blast radius if something went wrong.
Precisely. They basically stopped putting all their config eggs in one basket. They split their production Chef environment into multiple smaller isolated ones, prod 1, prod 2, up to prod 6, I think, and crucially tied each one to specific availability zones.
So bad config push only hits a fraction of their capacity. That's clever. Resilience in the management layer itself.
Yeah, exactly. And they also moved away from just relying on scheduled runs, the old cron job approach where a bad config could deploy everywhere right on schedule.
Right, which seems like asking for trouble. What do they do instead?
They brought in this thing called the Chef Summoner service. It uses signals, basically. It waits for a signal from their Chef librarian system saying, yep, this config is good, it's approved, go ahead.
Much safer. Less chance of a simultaneous fleet-wide disaster.
For sure. They do still have a cron job, but it's more of a fallback,
Yeah.
For compliance checks or recovery if needed.
Yeah.
A safety net, not the main driver.
Yeah, okay, so that's building resilience in. But then there's knowing if things are actually healthy. Let's pivot to observability. O11Y, as the cool kids say. We're seeing a big trend here, right? Companies moving off self-managed monitoring stacks. Seems like a lot of work to run yourself.
Oh, huge trend. And it's often driven by cold, hard economics, running something like Prometheus and Thanos at scale. It's complex, it's expensive, and it takes engineers away from building product features.
Got a specific example?
Yeah, Salesforce Commerce Cloud is a great one. They had this big self-hosted Prometheus and Thanos setup. They migrated it all over to Amazon's managed service for Prometheus. And the results were pretty stark. They reported a 40% drop in the AWS costs just for that monitoring piece. 40%.
Wow.
And maybe just as importantly, their engineers weren't spending time babysitting the monitoring system anymore. That's a huge productivity gain.
That's compelling. But doesn't moving to managed services sometimes mean vendor lock-in or less flexibility?
It's always a trade-off, yeah.
Yeah.
But I think for many, the operational simplicity and cost savings outweigh the need for super deep customization, especially when standards emerge.
Which brings us nicely to OpenTelemetry, right? OTLP seems to be becoming the standard way to ship this data.
Absolutely. It's becoming the lingua franca. And speaking of that, Datadog's new OTLP Metrics API caught my eye.
What's the significance there?
Well, it tackles a real pain point in modern environments, especially serverless. Traditionally, with OpenTelemetry, you needed some kind of agent or collector running alongside your app to gather and send the data.
Right, like a sidecar. Which doesn't really work well for things like Azure Functions or Cloudflare workers that just spin up and down.
Exactly. There's no long-running thing to attach an agent to.
Mm.
So this new Datadog API lets those functions send OTLP metrics directly to Datadog. No collector needed.
Ah, okay. So it closes that observability gap for those ephemeral serverless workloads. Makes sense.
Yeah, it simplifies things a lot.
Mm.
And then the health checks themselves are getting smarter too. Cloudflare's new load balancing monitor groups look interesting.
What problem are they trying to solve there? The classic false positive issue.
Pretty much, when one tiny part of your system has a momentary hiccup and suddenly your load balancer thinks the whole thing is down and triggers a big unnecessary failover.
Yeah, that's painful.
So Cloudflare lets you bundle multiple monitors up to 5, I think, into one logical group.
Mm.
It then uses a quorum,
Hmm.
like maybe 3 out of 5 need to fail before you consider the origin unhealthy. Plus, you can mark certain monitors as critical.
Hmm.
So you're making failover decisions based on the actual health of the important parts, not just noise.
Okay, that's much smarter. Better signal, less noise in your alerting, and failover. All right, so we've got resilient architecture, smarter monitoring. What about the engine that builds and deploys all this stuff? Let's talk about internal developer platforms. How are organizations maturing there?
Yeah, that's a key piece. There seems to be a pretty common maturity path that organizations follow when building out these internal platforms, usually like a 3-stage model.
Okay, walk us through that.
Well, stage 1 is usually just the basics, deployment pipelines, just getting code out automatically, simple CI/CD. Then stage 2 moves to secure pipelines. This is where you start baking in security scanning, compliance checks, governance, shifting left.
Makes sense. And the final stage?
That's the full DevOps pipeline. This is where it becomes a real platform. Think self-service infrastructure, one-click environment setup, integrated documentation, maybe cost visibility. The focus shifts heavily to developer experience, or DX, making it easy and fast for developers to do the right thing.
That developer experience point is crucial. If the platform is clunky, devs will just work around it, right?
Absolutely. Which kind of brings us to Jenkins. Still a workhorse in so many places, but often a source of, let's say, frustration.
The old love-hate relationship.
Yeah, but the material we looked at was pretty clear. The core problem usually isn't Jenkins itself. It's the lack of governance around Jenkins.
The Achilles heel isn't the tool, but how it's managed.
Exactly. Uncontrolled plugin installations everywhere, hundreds of Snowflake job configurations, weak access controls. That's what makes it fragile and hard to manage, not the core engine.
So how do companies make Jenkins scale effectively then? Is it just about imposing order?
Pretty much, yeah. Centralized governance is key. Things like standardizing on Jenkins shared libraries to enforce consistency across jobs. Having a dedicated platform team manage plugins instead of letting everyone install everything.
Yeah.
Using configuration as code or policy as code.
Trading that sort of Wild West flexibility for stability and scalability.
Right. You centralize the tricky parts so developers can focus on their application logic.
Okay, that makes a lot of sense for platform governance. Before we jump to AI, there was one really deep technical detail that caught my eye, talking about low-level performance. The BPF try thing.
Yeah, the BPF LPM try performance. That was fascinating. Definitely in the weeds, but with broad implications. BPF is used heavily in networking now, right? For high-speed packet processing in the kernel. These LPM tries are data structures used for things like routing lookups. And the deep dive found that when you start storing millions of entries in these tries, performance can really fall off a cliff. Lookups taking hundreds of milliseconds, which is forever in networking terms. And worse, just freeing up a large map could apparently lock up a CPU core for, like, over 10 seconds sometimes.
Wow. Okay, so that's a critical detail for anyone optimizing like core network functions or data planes at scale. Even the fundamental building blocks need performance governance.
Exactly. It's a good reminder that bottlenecks can hide deep down in the stack.
That's actually a perfect segue. We've talked about building, running, governing. Now let's look at the tools fundamentally changing how developers interact with code. Time for AI.
Yeah, it's moving incredibly fast, isn't it? And it's moving beyond just the code editor. AI is coming straight to the command line. GitHub Copilot CLI is the big example here.
Right, bringing that AI assistance directly into your terminal. For all those commands you kind of half remember and always have to Google.
Exactly. Things like finding the right git command, figuring out package manager syntax, debugging shell scripts. Copilot CLI can suggest the commands. And importantly, it seems to integrate with approvals. So it's not just blindly executing whatever the AI suggests. There are guardrails.
That's crucial. But for AI to be really helpful with your code, it needs context about your project, right? And that brings up the whole privacy concern. You don't want to send all your proprietary code to some public model.
Precisely. And that's where this idea of the Model Context Protocol, or MCP server, comes in. It's like a secure bridge. Azure DevOps just made their local MCP server generally available. The idea is it lets AI assistants get real-time context about your project without you having to ship your code off-premises.
Wait, how does that work? How does it keep the code local if the AI model is in the cloud?
Well, the MCP server runs locally, behind your firewall. It has access to your codebase. When the AI assistant needs context, the MCP server can provide relevant snippets or metadata without sending the entire source file. It's selective. OpenAI clearly sees this need too. They added MCP support to ChatGPT's developer mode, letting you plug in custom ways to fetch context securely.
Okay, so that's the secure context piece. What about the infrastructure needed to actually power all this? AI needs data fast.
Yeah, and that's pushing innovation in the database and caching layers. Amazon Elasticache adding vector search capabilities is a huge deal. It just hit GA.
Vector search in Elasticache. So super fast lookups for semantic meaning right in the caching layer.
Exactly. We're talking microsecond latency for searching potentially billions of vector embeddings.
And vector embeddings are those numerical representations of, well, of meaning and context, basically.
Right. So having this capability in a fast cache is fundamental for things like semantic caching for LLMs or powering those RAG systems everyone's building.
RAG being retrieval augmented generation. That's how LLMs pull in current specific information that wasn't in their original training data, correct?
Correct. RAG lets the AI ground its answers in your up-to-date proprietary info. Elasticache with vector search makes that retrieval step incredibly fast.
Got it. And beyond just retrieving info, AI agents seem to be getting more sophisticated at actually doing things. LinkedIn's update looked interesting there.
Yeah, that was a glimpse into the next step. Their updated GenAI stack lets agents, like their hiring assistant, actually think, plan, and act. They're using things like gRPC service schemas to define what actions an agent can take, and then orchestrating multiple agents together using their internal messaging system.
So moving beyond just chat responses to agents that can execute multi-step tasks autonomously.
Exactly. Agents as complex problem solvers, not just text generators.
Okay, wow. We've covered a ton of ground here, from learning hard lessons from cloud outages to AI assistants running commands in our terminals. If you boil it all down, it feels like there are a few key demands driving engineering right now.
I think so. First, definitely that need for extreme reliability. Multi-region, multi-AZ isn't optional anymore. It's baseline, driven home by those big failures. Second, the clear shift towards managed observability platforms, or at least federated ones using standards like OTLP. Teams just don't want the burden of running it themselves and need better ways to see into tricky environments like serverless.
Right. And third, the rapid integration of AI deep into the workflow, bringing context securely to the developer with things like Copilot CLI and MCP, and powered by new infra like vector search in caches.
Speed, context, and control seem to be the watchwords.
Definitely.
And maybe one final thought connecting all this back. All these improvements, these new tools and architectures, they're great, but their value really comes down to whether you can measure their impact effectively. The material touched on measuring engineering productivity. It's crucial that we do that transparently and without adding a ton of burden on engineers themselves. Otherwise, you risk just optimizing for busy work, not actual outcomes.
That's a vital point. Always keep the focus on the outcome, not just the activity. A perfect place to wrap up. Thanks for joining us for this look at the latest in, well, let's call it the nuts and bolts of modern engineering. Hope these insights give you something to think about this week. You've been listening to a discussion from the team behind Vocal Technologists. Until next time, keep optimizing.
Spoken Tech for your ears.